Alright, so what we talked about on Monday and what we're going to continue talking about today is we're talking about average rate of change, we're talking about finding the slope at a point, and then what we're going to now talk about is how to find like a tangent line at a point. Alright, so what we got to was we were talking about how if you have a nonlinear function, alright, we said initially, well, we're going to take so we talked about how you would take 2 points on a line and how we find the slope of what this right here is called a secant line. Alright? We talked about, okay, we can find the slope of the secant line by finding the average rate of change, which was f of b minus f of a, all divided by b minus a. Okay? And again, probably wrote this down on Monday. Alright? So, one thing I didn't mention on Monday is that this line that crosses through a graph or a function in 2 different places is called a secant line. Alright? That is a secant line. Right, now, this is what we call the average rate of change because it's not the exact, this gives us the slope of this line, which is sort of the average slope of this function between point A and point B. Alright? Now, our goal here is we don't want an average rate of change. We eventually want to get to the point where we are taking this and we are finding the slope of a line that's, or the slope of this function at this point. Alright? And in order to do that, we're going to have to get to finding the slope of tangent lines. Alright? So, we figured that out, that the average rate of change is f of b minus f of a divided by b minus a. And we moved over to this point right here, where we said, okay, we want to figure out actually what the slope is at a certain point. And what we did was we said, okay, this is the point we want to figure out the slope at. Alright? So we can start at like this point right here. And we're going to call that, instead of b, we're going to call it a plus h, where h is the distance from A to this point. Okay? So, what we then had was that this was f of A. So here, that is f of A. And then this point, that y value is f of A plus h. Alright? You guys remember this? Yes? No? Yeah. Alright. So, what we then said is, well, this is great that we can find this average rate of change between point A and A plus h, but what if we took this point and moved it closer? Alright? Okay, so we moved it closer. Well, now A plus h is a little bit closer. What happened to the distance h? It got shorter. It decreased because h is the distance between A and the second point. Okay, so then we said, all right, well, if we had it up here initially, okay, we would have a secant line that looked like this. We go. You have a line that looks like that. Alright? Well, then we said,
Excuse this interruption. Mr. Carter, could you come to attendance, please, Mr. Carter?
let's move this point down to here. Alright, so it was right there. Then you have a new line. Alright, between here and here. And what we see there is h, the distance got shorter. This is still a secant line. Alright? And what has happened now is this slope though of this secant line has gotten closer to the slope of that. It's a closer estimate of, or it's a closer approximation, of that slope at the point A. Alright? And so what we said we would keep doing is, okay, well, we could keep taking H and we could make it smaller and smaller until we got to that point where the distance would be what? That's A. What's the distance? So if we take this point right here, you take this point and move it from here to here to here, what's happening to the distance of H?
Good morning,
So
Linden-McKinley.
it's all the way to,
At this time, can we make sure that all attendance has been entered?
stop talking.
Also, please, teachers, don't send students to the nurse right now. She is working with the mobile unit, so she's technically not.
No! Wait. That was all done. So, what we did is, we said, okay, we can keep finding that slope the same way that we said. We said f of b minus f of a over b minus a, but we can make some adjustments. Alright, we said, let's actually let the slope equal. We're going to use what we used on this graph. We have f of a plus h minus f of a divided by, it would be a plus h minus a. Okay? And so if we simplify this a little bit, alright, we get f of a plus h minus f of a divided by a minus a cancels out, so now that's h. Cool. So here's the thing though. We said we're letting h get closer and closer to 0, which sounds like limits. Alright, so really what we're doing to find the slope here is we need to find the limit of f of a plus h minus f of a divided by h as h gets closer to 0. So what we're really saying is our slope now needs to actually be slope is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. Alright? So what this gives us, and this is something that you're going to use this now until about next week when you're going to learn about something else that actually is a shortcut to all this. So you guys have to do a lot of limit finding. But just knowing that you're doing that so that you understand why what we're doing next week works. Okay? You might touch that yourself, yes, but could do that. But the whole math work is for sure. Type math and this stuff. You can do it, but just use the trick. So now what does this represent? Well, this slope, okay, first of all, and you did not write this part down, write down, so you might want to write this. This slope is equal to the slope of a function at a given point. Alright, it is also equal to the slope of the tangent line of a given point. Alright, so it's the same type of thing. If I ask you to find the slope of the tangent line of a function at a given point, I'm asking you to find the slope of the function. Alright? So the slope of the function at a given point and the slope of the tangent line at a given point is the same sort of idea. You're finding the same thing, doing the same thing. Alright? So, what we're going to do is we're going to do one example of this, and then we are going to look at, again, how to do it on your calculator, so you can check your answers right now. And then after that, we are going to look at how this applies in finding the equations of tangent lines and normal lines. Okay? So, looking at this, yeah, we would add this. Alright, so to do this again, alright, you guys have this in your notes, I believe. Alright, so if we said we want to find, it says find the slope of f of x equals x squared plus x at x equals 2. Alright, well, what you would do here is you would take this function and you're going to use that definition of slope that we just had. Alright, where it says m is equal to, let's get a little fancy and use some calligraphy. Alright, we're going to use calligraphy, and we're going to go m is equal to f of a plus h minus f of a. That looks beautiful. It looks like real math handwriting. All over h. Oh, yeah. What I forget? I didn't get rid of it, I just forgot it. So we need to add that in. So let's move this over a little bit. And our calligraphy back. And we have the limit as h approaches 0. Okay, so this is our definition. Now, we have to make sure that we, notice some things. First off, we have to make sure, okay, h is going to just always be h. But a changes based on whatever the point is. So a is your x equals. So this is a. Alright? So what we need to do is we have, so the slope is equal to, now I want you guys to be using good notation here. So every time that you write equal to, you need to put the limit as h approaches 0. Alright? So it's going to be f of a, which is 2 plus h minus f of 2 all over h. Alright, so what you have to remember here, and this is what I'm working with, Greek gods, making sure they understand, is when you have f of 2 plus h, that means that you're doing is you're taking a function and you're replacing every x you see with 2 plus h. So we have, this is equal to the limit as h approaches 0 of, it's x squared plus x, I believe, so it's going to be 2 plus h squared plus 2 plus h minus f of 2, figure out f of 2. And this is something that you should find this at the beginning of the problem, is f of 2, you always are going to need to know this. It's 2 squared plus 2, which is 6. So I have minus f of 2, which is 6, all over h. Now, I like to do this next part sort of off to the side, just that way I have it all, nice and neat. 2 plus h squared means I have to expand that. So 2 plus h squared is 2 plus h times 2 plus h, which is equal to 4 plus 4h plus h squared. Okay. Now I'm going to have to add to that 2 plus h. So I'm going to add to this. I have 4 plus 4h plus h squared plus 2 plus h. That's going to be 6 plus 6h. No, 5h. 6 plus 5h plus h squared. Alright, so I'm taking this and I'm plugging it in for all that right there. That right there is f of 2 plus h. So I have this whole thing is equal to the limit as h approaches 0 of 6 plus 5h plus h squared minus 6 all divided by h. I then just need to start simplifying. 6's cancel out. This h and one of these h's cancel out with that h. So I'm left with the limit as h approaches 0 of 5 plus h. And at this point, I can plug my 0 in for h. Alright? Because it does not cause any problems. At the beginning, I can't plug it in because I have something over 0. So, what I get here is 5 plus 0, which is 5. So, our conclusion here is that this is that 5 is the slope of f of x at x equals 2. So, find the slope. M equals 5. Alright? Now, you might be wondering, well, how in the heck do I know that's right? Well, there's this nice little thing called a calculator that you guys know about. Dang it. Now everyone on YouTube will know. There it is. So, I need you guys to have your calculators out so I can show you this. I am going to have you guys check your answers on this, your homework and whatnot when you have it. It's your original calculator. Alright, so the way to check this is, first of all, you turn calculator on. Alright, so you're going to go to y equals, right, you got to type this in and then graph it. X squared plus x, alright, graph. This is one way to check it, this is another way to check it. Alright, so you get your graph up there, and talk about this on Friday, or Monday. You go, so anytime you want to do something with this function on this graph, you want to hit second trace. And we've been doing the slope, which, back in the day, it's changing y over changing x, which is dy divided by dx, where d is delta, which represents change. So you're going to select 6, alright, and it's going to pop up, and it's going to be blinking as x equals 0, y equals 0. So dy dx, that's finding the slope, alright? So what value do you want to find that? You want to find that 2. So you hit 2, it says x equals 2, hit enter. And it'll say dy dx, the slope is equal to 5, which means we win and we did on that play. And you can do this for anyone. You go to second calculus, or second trace, dy dx is equal to 6. Let's choose x equals negative 2. We hit enter. That says the slope is negative 3. Alright, now we can go through all that math again and check if you want. Well, you won't do that. So, another thing that you can do, let me just check. We're not going to be able to do that actually now. I can do that for myself. Alright, so, this is the math that you have to go through. You can quickly check it on your calculator. I need to see all your math to do this. So, you just look at how you can calculate the slope of that with your calculator. Alright? So, what we want to do now, and this says find the equation of the tangent and normal lines. So we have not done this. The first thing you're doing is finding the slope. Alright? Because we're trying to find the equations of lines. And in order to find the equation of a line, no matter what type of line it is, you need to know 2 things. First thing you need to know is slope of lines. Alright? Second thing you need to know is you need to know a point. So you need to have a point. Alright? And that's going to be A and F of A. Okay? So our goal right here is we're going to want to find the equations of the tangent and normal lines to f of x equals the square root of x minus 6 at x equals 8. Okay? So, what's the first thing that we want to do here? Find the slope. Alright? So, Now, first of all, what's our A value? What's A here? 8. Alright, so that's A. So we have f of 8 plus h minus f of 8 all divided by h. So we're going to plug all this in. So we have this is equal to the limit as h approaches 0 of plug 8 plus h in for x, so it's the square root of 8 plus h minus 6 minus f of minus f of 8 is just going to be 8 minus 6 is 2 to the square root of 2, or yeah, square root of 2, all right, and that is all over h. Okay, so we're going to simplify it. So two things right here. We're going to simplify this. Second thing is we know f of 8 is now square root of 2, so we're going to need to know that. So we know where our point is going to be 8 square root of 2. Okay, so we know f of a is equal to the square root of 2. All right, so this is the point that we're going to use to find our equations. So how do we simplify this? Well, first of all, we're going to get rid of some stuff. Limit as h approaches 0. The square root of 8 plus h minus 6 is just the square root of 2 plus h minus the square root of 2, all divided by h. Okay? Now we have some issues here. Okay, first of all, we can't plug 0 in for h right now. Can't do any simplification here. So, here's the thing, we want to probably get rid of this square root right there. Alright? How do we get rid of square roots? And how do we like to get rid of it? Not, okay. Not going to square. Alright? If I square this, I'm going to get more square roots. I'm going to multiply this by something. No, not 1/2. I'm not thinking 1/2 might show up. What we're going to do is we're going to multiply it by the conjugate. Alright? We're going to go square root of 2 plus h plus the square root of 2 divided by square root of 2 plus h plus 2, or plus the square root of 2. So what we're really doing is we're multiplying this by this conjugate, which is really just another way, fancy way of multiplying it by 1. Alright? So go through a bunch of manipulations here. This is equal to the limit as h approaches 0. So you're going to have the square root of 2 plus h times the square root of 2 plus h. That's just going to be 2 plus h. Square root of 2 plus h plus times the square root of 2 and minus square root of 2 times the square root of 2 plus h. Those just cancel out. So square root, so it's going to be the square root of 2 plus h times the square root of 2 minus square root of 2 plus h times the square root of 2. Alright, so those cancel out. There's 0. Alright, that's the nice thing about conjugates. There's never going to be any square roots that have to be multiplied to the top. Here, square root of 2 plus h times the square root of 2 plus h is 2 plus h. So then I'm going to have minus square root of 2 times positive square root of 2, that's going to be minus 2. Over, alright, so I have h times square root of 2 plus h plus square root of 2. I'm not really going to simplify that right now. Okay, so here's some cool things. Guess what? The 2 cancels out with this 2. So I'm now left with the limit as h approaches up. This h is going to cancel out with this h. Alright, so as h approaches 0. On top, everything cancels out, so I'm left with 1. And then I have square root of 2 plus h plus square root of 2. Okay? Now, I can just plug 0 in here. Alright? Plug 0 in for h, I'm left with, so this limit would be equal to 1 over square root of 2 plus square root of 2, which is equal to 1 over 2 square roots of 2. Alright? So this is our slope. And really that's not surprising at all once you know, like, see, me knowing where we're going, I know this right answer just by sort of already knowing something that I'm not going to say right now, because I don't want to spoil the surprise to you guys. It's like cake. That's how good it is. So, this is our slope. Now, whoa, we're not done, Shamar, relax. Okay, we have the slope. Do we have the equations for our two lines yet? All right, no. We need the equation for the tangent line and the normal line. Now, here's the thing that you need to remember. Okay, first of all, let's go back up here. So I'm just gonna, so first of all, normal means perpendicular. Alright? Tangent means it only touches at one point. Alright, so the normal line is perpendicular to the tangent line. Now, if we go back and think about what I said that this slope is equal to the slope of a function at a given point. It's also the slope of the tangent line of a given point. So, this slope we just found is the slope at the point x equals 8. It is also the slope of the tangent line. So, we now know the slope of the tangent line, and we have a point, which is right here. Alright? So, what you have to remember from algebra 1, alright, is good. You're going to do work here then. You're going to have slope intercept form. Y minus y1 equals m times x minus x1. Here's how sweet this is. You just have to plug stuff in right here. Alright? So, y1 was 8, or
Is that x1 at the bottom?
huh?
Is that x1 at the bottom?
X1 is 8.
I'm saying at the bottom though.
Yes.
What is that?
Alright? X1, Y1. So I plug stuff in. Y1 was, you said what? Square root of 2. Our slope was that 1 over 2 square root of 2 times x minus x1 was 8. You're done. Okay? You can get that so it says y equals. Don't, because you might make a mistake. And guess what? The AP test doesn't care. You leave it like that, you're right. Now, at times, if you're doing multiple choice, they may have it solved for y equals, but that's going to be a much simpler problem than this one. Alright? So, this is the equation of my tangent line. Now we need to find a normal line. Alright? Do you guys remember the relationship between a tangent line, or do you guys remember the relationship between the slopes of perpendicular lines?
No.
They are reciprocals and opposite sides. So the slope of our normal line, so m of perpendicular, alright, perpendicular means normal, is going to be equal to 2 square root of 2 with the negative sign in front of it. All I did, take the reciprocal, change the sign. So, the equation of our normal line is, again, we use the same formula. Y minus y1 equals n times x minus x1. We have y minus square root of 2, and that's equal to negative 2 square root of 2 times x minus 8. Normal line. I'm done. So, what we're gonna do here, okay, first of all, I want you to figure out, you can do all this on your calculator, alright? However, unless I tell you to do it on your calculator, you're not going to. So, what we're gonna do though is we're gonna do one problem on our calculator right now. So I want you to follow along here. So, it says, use your calculator to find the equation on the tangent line to the curve at the indicated x-axis. I sat down too soon. What two pieces of information do we need to know? Yep. So we need to know, and I said lines, we only need one line here because it's a tangent line, but so we need to know the slope. And what else? And the point, which is going to be a f of a. In this case, what is a? So this is a. How do you find f of a? What do we do? Nope. F of a just means f of x is this. So f of a, we just plug in our a value for x. So f of a is equal to negative 1.083 plus 4 divided by 1, negative 1.083. I'm just going to leave that there for right now. So first thing we need to do is find our slope. I don't want to have to find the slope of this by hand. And well, to be easy enough, let me rephrase. I don't want to have to do this slope using the limits. Alright? Right? So, I can use my calculator to find the slope. So what I'm going to do, you're going to follow along, take the calculator, y equals, there you go, y equals, it says x plus 4 over x. Actually, I'm not putting 4 over x in front. Just to be on the safe side. Okay? And graph. Now we want to find the slope. So how do we get to the function that defines the slope for us? Second and trace. Which one are we choosing? 6. And what was our a value?
Negative 1.03.
So we type in negative 1.083. Hit enter. And what's our slope say? Rounded to 3 decimal places. So it's negative. It stops at 4.1 because I set you guys to calculate up to round to 3 decimal places. So I'm going to do that for mine. So I'll go second, count, and then it's 6, negative 1.0 what? 3, hit enter. I get negative 2.41 as well. Now the reason it's negative 2.41 and you don't have all that stuff is because I set your calculator so it rounds automatically in 3 decimal places. Since the third decimal was a 0, it just isn't going to put it. Alright, so it's negative 2.410. So that's our slope. So n is equal to, what do we say?
Is that the y minus y1?
Yeah. Negative 2.41. So again, so at this point, this is something else that you need to have memorized. Y minus y1 equals m times x minus x1. So y is just y minus y1, where the, well, actually, you do need to figure out something. We need to figure out what y1 is. Our calculator can do that for us. We go here, we're going to type it, we're going to hit second trace, we're going to want the value, so we're going to hit enter. X is equal to negative 1.083. So y is 4.77 what? 6. Alright. So y is negative 4.776. So the y minus negative 4.776 is equal to, we said m was negative 2.41 times x minus x1 we said is a, so it's minus negative 1.083. And the only thing really we have to do after that is to simplify, get rid of those double negatives. So you have y plus 4.776 is equal to negative 2.41 times x plus 1.08. And that is tangent line.
We would think, hang on.
Questions about that? Now, what you guys have to do, so on your homework, you guys are going to have to do a lot of the limit stuff. Alright? But I need you guys to get that down and understand that. That way, when we get to the shortcut, it's not really a shortcut, but it's a nice little tool, alright? You'll understand why it works. Okay? So, that is everything. You guys want to see a few more examples of this, of like the limit part? Okay. So we'll look at another couple of examples. So let's say you want to look at.
No, choose one from the book.
Choose one from the book. Right. I don't want to choose one from the book. Stop. So, you guys, here we'll make a deal. Alright? We'll do one of your homework blocks. Okay, we'll do number.
Don't make it an easy one.
We'll do number 11. Alright? So, I'll be already done. Alright? So, what number 11 says is, so the function, there's 4 parts. Y is equal to 1 over x minus 1. And we're looking at x equals 2. Alright? So, the first thing we need to do is this. Okay, so you just find the slope, tangent line, normal line, graph. All 3 things. Alright, so find the tangent line, or find the slope first. You have to use the definition. Slope is equal to the limit as h approaches 0 of f of a plus h, which is 2 plus h, minus f of 2 all over h. Alright, that's equal to the limit as h approaches 0 of, there's going to be 2 plus h is going to be 1 over 2 plus h minus 1, minus f of 2 is going to be 2 minus 1, which is, so f of 2 is going to be equal to 1 over 2 minus 1, which is equal to 1 over 1, which is equal to 1. Alright, minus 1, all divided by h. Okay? Before I do anything here, I need to simplify the numerator and make it into one fraction. Or actually, we can do this first. The limit as h approaches 0 of 2 minus 1 is 1, so it's 1 over 1 plus h. minus 1 divided by h. Alright, so now the next thing I'm going to do is I'm going to take this, so I can combine these. I'll multiply this by 1 plus h over 1 plus h. Alright, so that gives me, we have the end of this. 1 minus 1 times 1 is 1, 1 times h is h, so minus h, divided by 1 plus h. Alright? That whole thing is divided by h. I'm doing bad notation right now. Alright? So, this is equal to 1 minus 1 cancels out. So I have minus h over 1 plus h. And this divided by h actually turns into times 1 plus 1 over h. Okay? So so what happens here is I have this equal to negative h over h plus h squared. And what you get here is the h is all canceled out. So you have negative 1 over 1 plus h. The limit as h approaches 0, so I can just plug. So I did bad notation here. Alright, I did bad notation. You're going to want to go back through and edit in like the limit as h approaches 0. So h approaches 0, that h goes away. I have negative 1 over 1. So my slope is negative 1. Alright? So the slope of the function at that point is negative 1. This is the slope of tangent. What would the slope of the normal line be? What would the slope of the normal line be? It'd be 1. So 1 is the slope of normal. And now you guys should be able to. Normal is always the opposite sign, and it's always the opposite sign is the reciprocal. So if it was negative 2, and that was the slope of the tangent, so that's tangent, the normal line would be 1 over 2. So it would be opposite sign and reciprocal. Alright? Alright. Your homework is whatever's in your notebook. It says you're on page 92, 1 through 6, part A only, and 9 through 14.